What's going on? Mr. Allen here. We're going to find the area of a regular octagon with an apothem measuring 9 inches. All right, now this is going to be a calculated problem, which is why I'm strapped up with that TI-84 Plus you see right there. So get yours out. Let's get after it. Let's go. All right, an octagon's got 8 sides, right? The apothem is 9 inches. It's a regular polygon, so perhaps we jot down our formula. Area equals 1/2 multiplied by my apothem, multiplied by my perimeter. So I need my apothem, I need my perimeter. Lucky for us, we've got one of them right away, right? My apothem is 9 inches. Now, when I start these problems, I don't like to draw the full octagon, okay? They're kind of tough to draw, first off. And second, you don't need the whole thing. What we want are just 3 of those sides, right? So we're going to do the base right here, the lower part, boom. And then I'll go ahead and throw one going up this way-ish, right? I don't even need the full thing. I just need a portion of it, and I'll even do a little dot dot, and then I've got this one going over here, okay? So I really need what I like to call an open-ended polygon here just to work with a little bit. Okay, so now that I have this open-ended polygon, I can draw my apothem, but perhaps I get a center going first up here, right? And then we can drop down that apothem, which is going to be at a 90-degree angle because it is going to be perpendicular to the side. Boom, this is going to be 9 inches right here. Okay, now I need my perimeter, which means that I need my overall side length. I want to get this length right here, right? That's a goal here, and then I can multiply that by 8 because there's 8 sides. But first, perhaps I need to figure out what this side length is right here. What that portion is, I'll call that x, okay? Now to do that, I'm going to use some triangles. So I'm going to draw in both of my radii of this particular inscribed, or this polygon here, this regular polygon, which can be inscribed in a circle, which is why I'm referring to them as radii, right? If I were to put a circle going around a regular octagon, all 8 vertices of that octagon would lie on the circle. It'd be inscribed. Okay, so with that information, what's this angle going to be right here? Better yet, how would I calculate that? Well, I would need to do 360 divided by 8, which is going to give me 45 degrees. That's what that angle is. But what I really want to figure out would be just this half of it right here, since that's an isosceles triangle because those are both radii coming down. All right, I can cut that in half because that apothem, that altitude of that triangle would bisect that angle. I'm going to get 22.5 degrees. Oh boy, we're dealing with decimals. This is just ridiculous. No, it's not. We can handle it. So I've got a right triangle here. I have a known angle of 22.5 degrees. I want the side that is opposite that angle, and I know the side that is adjacent to that angle. Whatever could I use if I have a side length and an angle that I know? How about some trig, specifically tangent, because I want my opposite, I know my adjacent, so that way I could set up tangent of my angle, which is 22.5, equals my opposite, which is x, divided by my adjacent, which is 9. This one is the easy algebra, multiplied by 9 and 9. So in my calculator, in that TI-84 Plus, I'm going to type in tangent of 22.5. I almost missed the decimal there. Let's see what that is in our good old friend, Mr. TI-84 Plus. We got 9 multiplied by the tangent of 22.5. Close those parentheses, and boom, that is my side length of that triangle. What do I need to do to get the full yellow one that I have there with the teacher brackets, right? I need to double that. So I'm going to multiply that by 2. That would be the side length of the octagon, right? Do I want the side length of the octagon for my formula of a regular polygon? It's helpful, but it's not what I need. I need my perimeter. If one side measures 7.4558, what do I do to get my perimeter? I'm going to multiply that unrounded number by 8. My perimeter is now 59.6467 and change. We got that jotted down. So now I have everything that I need, right? I've got my apothem. I've got my perimeter. I didn't even have to draw the full octagon, just the part that I'm really working with there. My area is 1/2 multiplied by my apothem of 9, multiplied by my perimeter of 49.6467 and change. Let's get that going in that TI-84 Plus. And I just realized I wrote down 49, not 59. Good thing I went back to that TI-84, you know what I'm saying? All right, 59.6467 and change. Woo! All righty, let's plug it in. So we got 0.5 So 1/2 or 0.5 multiplied by my apothem, which was 9 that was given to me, right? Multiplied by that 59.6467. And actually what I can do is I can hit second. And then if you look down here, it says ANS. Boom, it takes the previous answer, which was the 59.6467, and plugs it in for you. I get 268.41, 268.41. I am rounding at that point in time because this is my final answer for this particular problem. There's my area of that regular octagon with the apothem measuring 9 inches. That was dope. Bringing back trig. That was awesome. I hope you guys enjoyed it. I enjoyed it. All right. America Freedom, Rock and Roll, Costco, River Dog, Jenny on the gram. And you know what? Don't forget that yo-ro. You know what I'm saying? You only round once, right? Only once at the very end. That's what I'm talking about. See you.